All right, so my name is Lee Brown, and today I'm going to be talking coding serverless, the evolution of automation. So today we're here at Autoscaling in Anchorage, Alaska, and we're talking about security. And so one of the interesting things, me as a software engineer, traditionally when we're getting new products pushed to market, we think about security after we've finally pushed our first prototype to production. And so today our journey is going to be about what is serverless, and what I'd like for you guys to walk away with is how does this new evolution and trend towards serverless, how can security start to be incorporated a part of these systems that are provided to us as engineers for deployment and our build pipelines. So we're going to talk a little bit about what is serverless architecture, its advantages and disadvantages, and then specifically about two Amazon services, AWS Fargate and then AWS Lambda. So why listen to me? I've been programming for 20 plus years, 12 years in Python and PHP. Most recently, I've been doing all programming in Golang. I've been 8+ years using AWS Web Services. Should have invested in their stock when I first started using them. Love bootstrapping new products. And junior year in college, generated $1 billion in revenue, and so we kind of have this thing for how can we actually drive something and bring it to market. I founded a company 10 years ago based in Seattle, Washington, and now here in Alaska trying to figure out how do we build tech companies and other startups. So what is serverless architecture? So Mike defines serverless architectures as architectures that are application designs that incorporate third-party back-end as-a-service services and or include custom code run in managed infrastructural containers on a functions-as-a-service platform. By using these ideas or related ones like single-page applications, such architectures remove much of the need for traditional always-on server components. And so what does this ultimately mean? It means serverless doesn't mean remove of servers, it removes the management of servers themselves. And specifically, you don't, as software engineers with this the new evolution, you don't have to provision servers for management or specifically provision resources before you want to deploy to a new environment. Traditionally, built in is autoscaling, so the core concept between serverless is hopefully you're not paying for resources that are sitting idle, and ultimately all these with the evolution of cloud, availability and fault tolerance is native to these platforms. So how does it work? Well, serverless is all about spinning up new resources based on identifying the current demand and then using events to trigger the execution of code. So in the case specific of a web app, you have an incoming request. So instead of just going looking up what server is currently available from your predefined resources, you're actually going to go do a decision tree and figure out if there's actually a current service available that is underutilized and has the capacity. If so, the request will be served. Otherwise, you'll start a new instance of your code or container and handle the request, and then ultimately scale down or terminate the code after it's done. And so serverless, it can be used. It doesn't change the application or the types of applications that we can develop. It changes the way we deploy our code. And there's the big three cloud providers all provide serverless infrastructure. Today I'll be talking about Amazon Web Services, but Google Cloud and Microsoft Azure both provide similar alternatives. From one of the cool things that you'll see later as we walk through this, we're actually have successful implementations using both AWS Lambda and AWS Fargate in a single application, which gets beyond some of the traditional restrictions of merely just using functions to execute your code. So Amazon has been pushing the forefront of serverless, and we started way back here. All the cloud providers, it was always about the unit of scale was virtual machines, and it always went down to some sort of hardware. Then then came orchestration. So instead of managing the specific VMs, now we define some sort of task, and there's an orchestration layer that is handling the deployment of the code onto an OS. And now where we're at on the serverless side of things is we still define a task, the same thing with the orchestration layer, but instead of actually doing the provisioning on the OS level and that part of the requirement, the platform itself handles, at runtime, handles provisioning of services. And that's the same for both Fargate, which is service as a function, and then Lambda's function as a service. But both of these, their level of abstraction is at runtime. And so the first example I'll be talking about is using serverless to deploy a system for automating taking time-lapse of photos using a Sony camera, and then from there we're uploading those images to S3 and auto-generating videos. So we started out with our camera up here connected to my MacBook because this was our external power source. Now we got a Raspberry Pi, and now life is great. And then this is a bad image, but I was upgrading my Raspberry Pi, and my webcam's not working right now, but I'm in Anchorage, not Valdez, so I'll fix it when I get back. Don't have any robots in Valdez yet. So anyways, the images are captured, they're uploaded to Amazon S3, and then from there they go through our image processing pipeline and build a time-lapse video, and after that those videos are available. So just really cool, because now for me, instead of having to download all these images from my camera and then go back, do some sort of post-editing process, all I do is the images get uploaded into S3, and then videos like this are auto-generated for me. And so the goal of this project is to played these videos like 3 times just to hope they were cached. But so the goal of this project is to try to create a high-quality webcam so we can get, ideally at nighttime, long exposure, and also be able to identify the northern lights. And so you can see a traditional webcam is possible to take a video, or to produce a video like this. So it's pretty cool. We've got the northern lights. And then the fun thing that we've been doing is actually taking these photos. Every single time we process a photo, we also put it through Amazon image recognition service. We identify tags. So we can now, with this specific video, it was tagged with Aurora, and at some point we'll be building out a notification service so it will wake us all up when Aurora's out. We can see it live.
Nice.
We all have those Amazon Aurora apps, or not Amazon, everybody has a Northern Lights app, but they're never correct. And so this way, it's real-time eyes out there letting us know that something is cool in the sky.
Only get up on the Aurora is actually out there.
Exactly, because we have an eye out there watching it. And so, we got another video here, but just pretty cool. So we'll skip ahead. And so we're doing this all with utilizing AWS Fargate. So, and like as I mentioned earlier, the task or the unit of task is the unit of application logic that we're using for the deployment of this code. So as we first started out, as part of getting code pushed to production, we had to set up some EC2 nodes and create some sort of cluster for deployment of our code. And then we got services that would actually deploy our code, and specifically in the Amazon case, it was Elastic Beanstalk. Then we got ECS, which is starting to provide that orchestration, or it is providing that orchestration layer, where we define a task, and it's going out, and whatever service we're deployed on is determining what resources are available to run your code. And here, we're defining a task, which is really a container definition. Instead of actually having to pre-provision any sort of resources, the system itself, the platform itself, is provisioning all the resources for our code to run on. And so Amazon's ideal, they like you to think about Fargate is an easy way to deploy containers on AWS Lambda, so you can focus on building your applications rather than managing your infrastructure. And so this is, I think, one of the core components, and as you can see, Amazon's even trying to change the defaults on when people set up an ECS cluster. They're trying to get people, instead of using the classic way of setting an ECS cluster, they're already trying to get everybody to start setting up this new way of ECS clusters. And so what are the benefits? Well, you don't have to actually manage the infrastructure or manage the provisioning and scaling of your instances. Everything is handled at the container level. For me, that's great because all I have to do is define a Docker container, and with a Docker container, you get the ability to ensure that your code will run on multiple platforms, whether you're developing on your local laptop, and then that code can get shipped to your staging or production environment. And ultimately, it scales without, as an engineer, with minimal effort or work. And so how does Fargate work? Well, you build an image. So this really, currently, I like to think majority of engineers, they're already using Docker containers. And so you build a container image, and then you push it up to Amazon ECR, that's the registry service. And then you define your tasks. So what resources? Basically CPU and memory. And once you have that, Amazon takes care of launching your Docker container that you have defined, and then also scaling and up and down of services based on demand. So in our case here, the Sony camera, it's being controlled by a Raspberry Pi. And it's, after each photo it takes, it's uploading our image to Amazon S3. Amazon has this concept of event notification. So every single time an image is uploaded, it's automatically creating an event notification, and Amazon has a service called SQS, which is a queuing service. And so here, every single image that's uploaded gets basically a JSON message that says, here's the image path. Then we have our application that's deployed in Fargate. That's our Golang code that manages all of this stuff. So we are pooling the queue for new messages, and then as a new message comes in, we'll process it and dump the image back out to Amazon S3, which is ultimately then served to the end user on the website. Well, the cool part then is this is one image, but as we increase the interval that we're actually taking photos, we have an Amazon CloudWatch alarm that's basically monitoring the number of messages in our SQS queue. So if our SQS messages increase in size and we're getting a backlog of messages because we're taking photos too fast, AWS Fargate will get triggered from the alarm and start adding more instances to process the additional number of images that we've generated. And so with our website geeksinthewoods.com, you still have this concept of EC2 backed clusters, which is the classic way of setting up an ECS cluster, and then you have Fargate, this is the completely serverless method. And then there's two different ways. One is you can, for auto-scaling your application. One is target tracking, and there's two options, which is either memory utilization or CPU utilization. And so they're just monitoring the memory of your CPU, and then it will spin up additional servers until that alert has gone below that threshold. Or the cumulative average of all your servers that are online has gone below, or not servers, containers have gone below that threshold. Or the other one is step scaling. So, and this is what we're using for our Amazon image processing service. So if there's 100 images in the over 100 images in the backlog, we'll add another instance. If there's over 500 messages in the backlog, we'll add 2 more instances. And so it gives you some flexibility of how to actually scale your application. So that's Fargate. So Fargate is really providing automation around the deployment of your code, deployment of your Docker containers to Amazon. The next is AWS Lambda, and so Lambda, instead of the function of application logic being a task or a Docker container, the unit of application logic is your function. So you're taking a chunk of your code and actually uploading that code to Amazon for execution. And so we've we're basically AWS is still in my mind and how this works. we're still using containers to do build and deploy as part of our build pipelines. But ultimately, after we've built our container and it's passed all of its tests, we extract our code from this Docker container and then upload our specific our application logic as a function, so just the raw code, up to Amazon for them to execute in their environment. So this changes kind of how you utilize Amazon's resources, and because of that, it has a little bit different model. Whereas Amazon, on traditional Fargate, you're paying for hours used based on memory and CPU. Here, you're paying per execution, and each execution of your Lambda function has an associated cost based on CPU and memory. So what does this change? How does AWS Lambda work? Well, you have some sort of event source, whether images getting uploaded to S3 or it can be pretty much anything on this side. And as soon as an event has been identified or some sort of demand, it triggers an AWS Lambda function, and that's basically your code. It can be in Python, Java, C#, Node, and also Golang. And then the outputs can be pretty much anything, as long as you have access, whatever your code has access to via your IAM policies. There's endless possibilities on what you can do. So what does that mean? Well, the cool part about AWS Lambda is for each execution, you have the ability to specify allocation resources. So whereas with Fargate, your resource allocation is based on the Docker container that task that you've defined. With AWS Lambda, you can actually define your resource allocation based on the specific inputs of the function. So in our case of a good example is we're processing documents, and this document is 120 meg PDF. We're probably going to need more than 120 megs of memory for our Lambda function to actually execute properly. So it's pretty freaking cool as far as that goes. But one of the major challenges with Lambda function is you have this constraint of 300 seconds, so it's micro-batching, essentially, and that's where you get kind of. Lambda is great, allows you to pay specifically for execution of a function, but you can't run your application inherently as a service on AWS Lambda. So there's multiple execution models with AWS Lambda, whereas you can invoke a function and then wait for its results. Traditional web request model, you have asynchronous with uploading, utilizing some sort of event to trigger a Lambda function in the background, or then you have the streaming based with Amazon Kinesis and AWS Lambda. So Lambda can be triggered by anything. It's pretty freaking cool. With Amazon specifically, they have Amazon SDK packages for almost every language, so whatever you're programming in can theoretically be a data source to trigger an event. There's a startup here in Anchorage called Legal Thread, and what they're doing is they're basically providing, in this specific implementation, they're Bates numbering PDF documents. And this is a case where we're combining both AWS Fargate and AWS Lambda to help make this happen. So we have a user who comes in and they hit the web interface, and at the web interface they have the option to upload documents. So you have one user, but you have an infinite possibility of documents to upload. The traditional route would be, upload the document, and then on the service itself, then let's go do the document processing. And then if the document processing spikes CPU usage or memory, then we'll scale these workers up. And we've now, with AWS Lambda, offloaded all of that additional utilization onto a scalable set of tasks. So from our AWS web service, we're now invoking a blocking call to AWS Lambda, and then executing we're executing the logic to add a Bates number to the PDF itself, and then the application is then notified that it's done. And so because we're in Go, we have concurrency built in, we're able to have multiple background threads sitting there waiting for a response, and when the response happens, then we can notify the user that the document is ready to go. So you can see that this in and of itself, Fargate in and of itself is still kind of has those legacy auto-scaling, where if you want to scale up because the user wants to upload 1,000 documents, you're going to have to wait for those instances to scale down. So here, if you have a consistent, relatively low number of consistent or concurrent users, we can offload any additional processing to AWS Lambda and won't drastically increase our overall AWS bill, besides for the specific use cases that we're utilizing. So this is really cool. So we're still using, for our AWS Lambda function, as we're deploying to the platform, we're still utilizing Docker to build our Lambda function. And then at the end, after we have this Lambda function, we're copying our static binary that's been compiled outside of the Docker container, and then we're generating a zip file that includes that Docker that executable binary, and uploading that to AWS Lambda. So you can see down here, instead of traditionally if you're using like either Golang base image, it'd be like 80 to 120 megs. And so down here, our actual code size of our function that's sitting there waiting to be executed is 7.5 megs. So that's what's awesome about Go, and why Go works really well with AWS Lambda, is because with AWS Lambda, everything is a cold start. So if it's got to load 120 megs of 120 megs of your application to actually get started, it's going to have a little bit of latency. And so yeah, coding with serverless is now, it can already happen. It doesn't change or limit the types of things that you can do, but it is going to be the future, and that's what makes it really exciting. But I hope that at some point we can start to include more of these awesome security startups. If they can start including more of their great tools in part of this infrastructure that's currently being developed. There is some challenges, obviously, from the IT infrastructure itself. We're changing everything on that. So monitoring is still a new issue that has to be addressed. We have cold starts with AWS Lambda, or even just scaling your Fargate containers as well. Dell workflow changes a little bit. Application architecture obviously changes quite a bit because you're having to deal with service discovery and how your services communicate with each other. So with that, it's really exciting. I've been chatting with a few people, and one of the things we've been chatting also with Jeff, the Alaska Developer Alliance, and one of the things we're interested in doing is hosting a meetup, or a workshop rather, to get individuals, whoever wants to walk through and actually get a serverless build pipeline set up using GitLab and Golang with AWS Fargate. That's something that we're working on setting up. So if you're interested in this, definitely chat with me afterwards, and we'll get something scheduled. Cool. Any questions?
Yeah, one.
Yeah.
So one of the things that can be really challenging is having to maintain infrastructure to deal with